Hello everyone, I hope you all are doing well. Welcome back to the AWS AI Engineer Essential series. My name is Dheeraj Choudhary and today we are diving into IAM for AI ML workloads. So IAM is known as Identity and Access Management, and this is how AWS controls who can do what with your resources that you have created. So let's get started. So let's start with the fundamentals. What exactly is AWS IAM and why does it matter for your artificial intelligence and machine learning workloads? IAM controls who can access what in your AWS account. Every action in AWS, like launching an EC2 instance, reading from S3, training a SageMaker model, requires proper IAM permissions. Without IAM, anyone with credentials could access everything in your account. Now, IAM manages authentication and authorization. So, authentication verifies who you are, like your username and your password, or the access key, which proves your identity. Now, on the other hand, authorization determines what you can do, like which services you can use, which actions you can perform, and which resources you can access. It's a free service with no additional cost. Unlike most AWS services that charge based on usage, IAM is completely free regardless of how many user roles or policies you create. There is no reason not to implement proper security controls. IAM is critical for security and prevents unauthorized access. So, misconfigured IAM is one of the top causes of data breaches in your cloud environments. For artificial intelligence and machine learning workloads, handling sensitive training data, customer information, or proprietary models proper IAM configuration isn't optional, it's very essential. Think of IAM like company ID badges with different access levels. An employee badge opens the main office and their department. A manager badge also opens meeting rooms and equipment storage. And an admin badge opens everything including server rooms. So IAM works the same way. Different identities can get different permissions based on what they need to do in their job role. So IAM has four core components that work together to control the access. Understanding these building blocks is essential for securing your artificial intelligence and machine learning workloads. So user represents individual people or applications. Each data scientist or machine learning engineer on your team gets their own IAM user, like machine learning engineer John, ML engineer Sarah. Applications and scripts can also have dedicated IAM users with programmatic access for API calls. Now, groups on the other hand are collection of users with similar permission. So instead of assigning permission to each person individually, create a group like ML team, data scientist team, or machine learning engineers and add users to your groups, and they are going to inherit all the group permissions automatically. This makes the management much easier at scale. Now, roles provide temporary permission for AWS services. So, unlike users with permanent credentials, roles are assumed temporarily. For example, a SageMaker training job assumes a role to access S3 buckets to train the model and save artifacts. Then the permissions expire when the training is complete. So, roles are also used for cross account access and federated users. Now, policies are JSON documents defining permissions that allow or deny specific action. A policy might allow S3 get object, S3 put object on a specific bucket, but it can deny S3 delete bucket. So policies specify exactly what actions are permitted on which resources under what conditions. Now, one of the key concepts that you need to remember is policies attached to users, groups, or role to grant permission. The policy is the rule book and you attach it to the entity that needs those permission. A user without attached policy has zero permission. A role without policies can't do anything. So the policy is where the actual permission lives. So why IAM is so critical, especially for AI/ML workloads? So let's explore the unique security challenges that machine learning brings. So AI/ML services needs access to your data in S3 buckets, like your training data sets, validation data, and the test sets all live in your S3 bucket. SageMaker, Bedrock, and other services must read this data to function. Without proper IAM permissions, they cannot access the data which you have added to the S3 bucket. And with overly broad permission, they expose sensitive information too. So SageMaker needs to write model artifacts after training completes. SageMaker saves the trained model checkpoints and logs back to S3. So the training jobs IAM role must have write permission to designated output bucket, and if the permissions are missing, training fails even after hours of expensive GPU compute. This is that critical. Prevent unauthorized access to sensitive training data. So training data sets often contain PII, that is personal information, financial records, medical information, or proprietary business data. So one misconfigured IAM policy could expose this data to unauthorized users or even the public internet. So proper IAM ensures only authorized services and people access this sensitive data. Now, compliance requirements like HIPAA or GDPR need proper access controls. Regulations made strict controls over who accesses protected data and detailed audit trails of all access. So IAM provides the granular permission, and CloudTrail logging is required to prove compliance during the audits. Now, a practical example would be a SageMaker training job needs to read data from S3 and write the trained model back to S3. So the execution role attached to the training job must have permission to S3 get object on the input bucket to read the training data, and S3 put object on the output bucket to save the model. And without both this permission not configured correctly, the job might fail. Now let's understand the least privilege principle, which is the golden rule of IAM security. It's simple but powerful, and following it prevents most security incidents. Grant minimum permission required to do the job. Users and services should only have specific permission they need, nothing more than that. If a training job only reads from one S3 bucket, don't give it access to every bucket in your account. Don't give full admin access when specific permission suffice. It's tempting to grant broad permissions to avoid troubleshooting access errors, but full admin access means unrestricted control over your entire AWS account. One compromised credential and it could delete everything, launch expensive resources, or expose all the data of yours. So reduce security risk if credentials are compromised. When credentials leak through exposed code repository, phishing, or stolen laptops, limited permission contain the damage. An attacker with read-only access to one bucket causes far less harm than one with admin access to your entire account. That's why least privilege principle is so important. This is an AWS best practice for all the services. AWS recommends least privilege across every service and every scenario. It's particularly critical for AI/ML, where data scientist needs experimental freedom, but security team needs strict data governance. Now, let's see one good example and one bad example. Let's start with the bad example, where we give SageMaker full S3 access to all buckets. This policy allows S3. So when we are going ahead and providing full access, at that time, what we would do, we would go ahead and give the permission like this by saying S3 colon, and I will provide here star. This is a wildcard. So it is going to give all the permission of S3, right? And that is actually a bad example. So instead of that, you should give access only to specific ML data object, and this allows and this policy is going to allow S3 get object and put object only on a specific S3 bucket that we have created. So that is how you define. So never ever give permissions like S3 colon star. Instead, provide permissions like S3 colon get object and S3 colon put object. Now, it does not ends over here. While you provide both this permission, you also have to make sure that you provide this permission to a specific S3 bucket on which it is going to work. That's it. So in that way, you can provide in the policy the ARN of the S3 bucket where it should have the access. And this is the good example. Now let's break down IAM policies. So understanding the JSON structure is the key to writing secure, precise permissions for your AIML workloads. So policies are JSON document with permissions. Every IAM policy is written in JSON format with specific fields that define exactly what's allowed or what's denied. You attach these policies to user groups or role to grant permissions as we discussed earlier. Now, policy components are one of the policy component is effect, which allows or deny. This field specifies whether the policy grants permission, that is allow, or explicitly blocks it, that is deny. So deny always wins. If one policy allows an action but another denies it, the action is blocked. Next comes action. So what can be done? Action specifies the operations you are permitting, like S3 get object to read file, S3 put object to write file, or SageMaker create training job to create a training job so that you can start the model training. You can list multiple actions or use wildcards like S3 colon star, which is not recommended for all S3 operation, but there might be a scenario where all operations should be available for the SageMaker. At that time, you can use S3 star, but you can still limit it to a specific bucket. Now, resources, which ARN resource? So this resource field specifies exactly which resource. So in our case, which S3 bucket it is going to target for which it is going to perform those specific operation. So let's understand this with an example. So over here, I have given one example in which what exactly the policy is doing is the policy grants permission to download files from my ML data bucket. That's it, nothing more. So the training job can read data but can't write, delete, or access other buckets. And this is the least privilege in action. So if I go through this, so the first step says us that allow action. What action is allowed? It can read from the bucket. Once it understands it can read, then it will go and search for that specific bucket. So now when I say slash star, so all the files inside this bucket can be accessed by the SageMaker job. So if we provide this policy, then our job is ready to read the data. Now, IAM roles are essential for AIML services. Let's understand why services use roles instead of traditional credentials and how this works in real practice. So AWS services like SageMaker and Lambda can't use usernames and password. Services don't log in like us as humans. They need a different authentication mechanism that's secure, temporary, and doesn't require managing static credentials. Use IAM roles instead with temporary credentials. Roles provide temporary security credentials that automatically rotate. When a service assumes a role, AWS generates a temporary access key that expires after a set amount of time. This is far more secure than permanent credentials that could be stolen. The role defines what the services can access. You create a role with attached policy specifying exactly what permissions the service needs. For example, a SageMaker execution role might allow reading from S3 buckets, writing logs to CloudWatch, and accessing ECR for container images if it is processing any processing any Docker file and creating an image out of it. The service assumes the role when executing. So when you launch a SageMaker training job, you specify which execution role it should use. So SageMaker assumes that role gets temporary access and uses those permissions throughout the training process. And when training completes, the credentials are going to expire. Now, common AIML roles that you might be coming through while we are going to go through this tutorial. At that time, one is SageMaker execution role, which is going to provide access to S3 and CloudWatch. And this role allows SageMaker to read training data from S3, write model artifacts back to S3, and send training logs and metrics to CloudWatch for monitoring. So every SageMaker training job, processing job, and endpoint requires an execution role. So this kinds of role you would have to create. Another example is Lambda role for invoking SageMaker endpoints, because if you build a serverless inference API using Lambda, the Lambda function needs a role with permission to invoke SageMaker endpoints. This allows Lambda to send prediction request and receive model outputs without storing credentials in the code. Now it's time for us to do some hands-on. So as part of this hands-on, what we are going to do is we are going to break down this in 4 steps. So the first step over here is we are going to go ahead and create IAM user and role for SageMaker. Then we will go ahead and attach policies for S3 and CloudWatch access. Then we will test our role for SageMaker launching book in our next video. And I will show you how we followed the least privilege principle over here. So let's see our first step. So our first step is we have to sign into AWS Management Console, search for IAM at the top, click on IAM service. On the left side, you click on roles and users and you create the user and role. So first, I will take you to our console. This console, search for IAM over here. Once you search for IAM, just open this in new tab. So this is your tab. So over here, first go in users and click on create user, and we will be creating a AI underscore ML underscore user. Provide access. I will give my custom password and I will just uncheck this. Next. So I don't want to add user to any group. Now over here for this user, you should provide a least privilege based on the actions that you would be doing. So for example, if you are a machine learning engineer, you should have access to S3 bucket. Then you should have access to different Amazon Bedrock or some inference point for Lambda. But as I have to do this tutorial for you end to end, I would be creating user once. So I am going to use admin permissions, which is not the best practice. So you should not use it. But from this setup, you understand at least how to create a user. So while you're going to do, your work is going to provide, see, search for SageMaker, and it will give you Amazon SageMaker permissions. So based on your operation that you have to perform, you can use any of this. Okay. Now I will click on next and I will click on create user. So my user is created. I'll return to. So I will just copy this details so that it will be easy for me to log in later. And password. So we are done. I will return to user list and click on continue. So once I am back, my next task would be to go back to IAM and click on roles. Now we are going to go ahead and create roles. So what role we have to create? We have to create an IAM role, and that IAM while creating the IAM role, we have to make sure that we are selecting the trusted entity type. Then we are selecting SageMaker into it, and we select SageMaker execution radio button while we are going ahead and creating the role. So I will first of all click on create role. Once I create role, then I have to go ahead and say custom trust not custom trust policy. I would say AWS service. Over here, I will select SageMaker. Once I select SageMaker, so as I showed you over here, you have to select SageMaker execution radio button. So we will select SageMaker execution radio button and click on next. Once we click on next, so automatically it has provided full permissions to us, and which will allow it to assume the role. But if you want, you can also set permissions boundary over here by selecting this. Then I will click on next. And now once we are done, so we can go ahead and give it a name, SageMaker full access. See, by default it has said allow SageMaker notebook instance, training jobs and model to access S3 ECR and CloudWatch on your behalf. So if you see, we have a trust policy where we are providing SageMaker. Then this policy, if I click on this and show you what all permissions it has, So you can see CloudWatch, CloudFormation, all these permissions it would require to work. So it has automatically granted that, and I will create the role. Now, once your role is created, so the next part would be just to check if that role has been created successfully. So either you can just copy this and search over here. See, it is showing. So this confirms our role has been created successfully. Now, role name we have already provided, description we have already provided, we have already reviewed and created the role. Now we have also verified by checking whether the role exists or not. And why this was very important, because when we are going to create our first SageMaker job, the first and foremost thing it is going to ask us the role ARN that we have just created. So that's why this is a prerequisite for our upcoming video where we will start creating SageMaker training jobs. Now let's understand what we have created. So understanding each component will help us know that how we secure our machine learning workloads properly. So the trust policy that we selected. So the trust policy says it allows SageMaker service to assume this role, and this is specific JSON document that says I trust sagemaker.amazon.com. So I am talking about this policy. If you go over here, trust relationship, see, I'm talking about this. So trust policy says that it trusts sagemaker.amazonaws.com to use this role. So without a trust policy, SageMaker can't access the role even if it has the right permissions that we have attached to it. That is the full access. So the trust policy is going to control who can wear the badge, while permission policies control what badges unlocks. Now the permission policy defines what SageMaker can do once it assumes the role. That is part 2. These are the actual capabilities granted to the service. So I have already showed you that what all capabilities it comes with as part of the permission. So these are going to be all the capabilities that it would be having. I mean all the permissions. Then comes access to S3 bucket. So right now we have not provided specifically permission for S3 bucket or not, but when you're going to create this in real time, you should create attach a custom policy where you can give S3 object, that is get object, and S3 put object. So these are the two permissions because that would be required to pick the data from the raw data file, and when the job is done, the machine learning model is trained, it is going to output the model out of it. Then for writing logs to CloudWatch for monitoring, SageMaker is going to send training, progress, metrics, and error logs to CloudWatch logs. So the execution role needs logs create log group that we already have. It also would require log stream so that it would be able to create the logs in CloudWatch. And then the full SageMaker operations, the role might include permissions like SageMaker create job, SageMaker describe job, training job. So these all permissions are already coming as part of SageMaker full access when we selected SageMaker execute. Now the security note, we are doing this just for our training purpose. In production, replace the full access SageMaker policy with specific buckets, resource permissions, and limits. So that is very important. Now let's cover essential best practices for IAM in AIML workloads. So following these guidelines prevents security incidents and keep your ML infrastructure secure in production. So use roles for services, not hard-coded access keys. So use role for services, not access keys means never embed AWS access keys directly in your training scripts, notebooks, or application code. Hard-coded credentials can leak through Git repositories, logs, or error messages. So instead, attach IAM roles to EC2 instance, Lambda functions, and SageMaker job so they automatically receive temporary credentials. Then create separate roles for different environments, like for dev environment and production environment. So your development environment shouldn't have the same permission as production. Like dev roles might allow broader experimentation and logging, while production roles are going to enforce strict least privilege and restrict write access. So this isolation is going to prevent accidental production changes during testing and limits damage if the dev credentials are compromised. Now, regularly audit and remove unused roles and policies over time. So teams create roles for experiments, test projects, and temporary tasks that accumulate permissions. Use IAM Access Analyzer to identify unused roles and overly permissive policies. Schedule quarterly reviews to delete unused identities and tighten permission based on actual usage pattern. So if I take you over here, you will have one access analyzer. So when you use this access analyzer, by using this, you can go ahead, create an analyzer, review the findings, and then take the action. So it is going to help you understand that which are the policies which are having extra permissions, which is risky, and which are the roles or policies which are never been used but still they are being created. And here is the pricing for that accordingly. Then enable multi-factor authentication for IAM users. So multi-factor authentication adds a critical second layer of security beyond password. Even if an attacker steals a password through phishing or credentials, they can't access the account without the MFA token. So you can enforce MFA organization wide by creating policies that deny all action unless MFA is present. Now use CloudTrail to monitor IAM activities. Why I created a SageMaker user? Why companies create a user and allocate you to that specific user? The auditing becomes easy because CloudTrail is going to log every API call in your AWS account, including who assumed this role, what action they performed, and when. So the role that we are creating, we would know that which user has assumed it or which IP has assumed it. Same for user. As a user, SageMaker user, AIML user, if I'm going to perform any activity, it is going to get logged. So companies know that who is doing which activity. And that covers the essential for IAM for AIML workloads, where we have explored what IAM is and why it's critical for security. We learned the core concepts like users, group, roles, and policies, and understood why least privilege is the golden rule. So if you enjoyed this video and want to keep learning step by step, make sure to like the video, subscribe to my channel, and hit the bell icon so you don't miss the upcoming tutorials. Thanks for watching, and I will see you in the next video.